All right, students, here we are again. This mostly should just be a review for you guys, okay? This shouldn't be any real new information. This is sort of a wrap up, okay? Chapter 12 starts on page 354. So we talked about OBD2, right? Universal Diagnostic Connector, the DLC, standard location in the driver's footwell. Um, Standard communication protocol. So we have the 10.7 kilobit speed, and then we have CAN after 2008, right? Use of common scan tools will tell you everything you need to know, right? Um, let's see, what else did they add? They added common diagnostic test modes, right? So mode 1, 2, 3, 4, 5, 6. The stuff that I don't generally get into very much simply because I never used it. The factory never really taught me to use that. So as a consequence, I don't get into it too much. Let's see, what else? Vehicle identification must be transmitted to the scan tool. Stored trouble codes you're supposed to be able to clear. Ability to record and store memory and freeze frame, which is a great idea, except that by 2008 the computers are so fast and doing so many things that it's unreliable, in my opinion. Not all of it can be used, as we discussed. So obviously we're looking for 14.7 to 1. Accurately control emissions devices such as the EGR and the purge valve and things of that nature, right? Control ignition timing, cold engine operation, et cetera, et cetera. So let's see, computer operation, input, processing, storage, and output. Obviously, if you get an input, it has to be able to figure out what to do with that. That's where processing comes in. So it takes that value, plugs it into a bunch of other things it already knows, and then goes ahead and makes an output, if that makes sense. Okay. The storage part comes in because it has, when I see X and I see Y and I see Z over here, that's where I wind up. So if that's the case, then it's doing what it's supposed to do, right? Everything in there is done with circuit chips. It's all solid state device at this point. No relays or anything like that. All the relays at this point are external. Yeah, how they design microprocessors, they etch the integrated circuit on a chip, and then that circuit knows what to do when you apply voltage here and there. It makes its decision. You guys have learned that with Arduinos, right? Let's see. Programs are nothing more than a group of instructions that the computer's supposed to follow. Information storage, that's one of the functions of the EEPROM, isn't it? Right? So that EEPROM holds all the functions that the computer is supposed to do when it sees X, Y, and Z, and it says, oh, we're going to go to our lookup table. We're going to go ahead and use that. We're going to plug in that information, and this is going to send us here. And that's what we do as an output, right? Random access memory, we've talked about that before. This is nothing new. Random access memory is something that it remembers, but it only remembers it until you remove power. Then it doesn't remember it anymore. Okay, read-only memory, or in this case, EEPROM, right? Electronically erasable PROM. So whatever we choose to program it with to tell it to do, or this is your lookup table, use this, right? That's all written onto that PROM. And that part can't be erased, okay? That's where it starts over from. That's where the operating system is. And then it goes to all of the program files, and it knows what to do when it gets power, okay? What else is in here? Let's see. So programmed read-only memory used to be a chip, okay? an actual prom. It was a hard chip. It was about that long, about this tall, pardon me, and about that wide. And you would just pop it in and out of the computer. So you would pop it out. If it had a problem where there was some bad information on that prom, you would simply replace it with a new one. The other flip side to that is if you're replacing the computer because the computer's not doing what it's supposed to do, then you have to transfer that prom from the old computer to the new computer. Otherwise, it won't have all the lookup tables it needs to work. Keep alive memory. That's similar to the RAM. Anytime that the computer wants to remember something, it'll put it either in RAM or keep alive memory. Keep alive memory will stay until you remove power. Okay, so that will stay until you remove battery power. RAM typically erases when you shut the key off. All right, adaptive strategies. Computers will learn and they will put that information into the keep alive memory as a rule because that's something that stays viable. So if it remembers that the car needs, 4% extra fuel under these conditions until you remove the battery, positive cable or negative cable or both, it will remember that. So it won't have to relearn it every time you start the car. Okay. So let's see, there's your adaptive strategies, OBD2 components. Systems must eliminate the mill if it's going to exceed 1.5 times the allowable standard. The interesting thing is sometimes they will and sometimes they won't. And some of the reasons that they won't might include the fact that you never actually hit the parameters to test for that, if that makes sense. So let's see. Also, oxygen sensors, right? Heated oxygen sensors. We are looking for a minimum of 2. Bank 1, sensor 1, bank 1, sensor 2. Sometimes you will have bank 2, sensor 1, bank 2, sensor 2. And sometimes you will have bank 1, sensor 3. Now, I've only seen that in a very few cases. One of those cases would be on older S&T trucks. You'll have one on one side, one on the other, and then the third one, bank 1, sensor 3, is behind the cat. So there you have it. At any rate, and they do show that here on page 363, so that's a good reference, right? So looks like they've got a pre-converter and then a post-converter. Here on 363, they've got dual converters, and behind the second converter is where they put that sensor 3. So also remember, bank 1 always goes with where the number 1 cylinder is. Bank 2 will always go on the other side. Okay, so if I tell you that bank 2 is lean, then you know that it's the bank without number 1 in it. Computer programming and memory. It's like we talked about, we've gone to a double EEPROM, right? Electronically erasable. So we go in there, we erase it, and we say, this is what we want you to know now. And we upload possibly a new operating system, depending on whether or not it needs it. And or we'll just update the calibration files. It just depends on what that particular update needs, right? Let's see, we wanted to talk about monitors a bit. Catalyst efficiency monitor, engine misfire monitor, fuel system monitor, heated exhaust gas, oxygen sensor monitor, EGR monitor, EVAP monitor, secondary air injection monitor, thermostat monitor, PCV monitor, comprehensive component monitor. So these are all things that the computer will test for, okay? Now your flags, remember how I went to the IM system status and it said catalyst done and air injection done, or it said yes, no. So those are your flags. That means we've run all of the component tests in each one of those monitors and they've run and passed or run and failed. Okay, so but all of the tests within that monitor are complete, if that makes sense. All right, that's all the flag tells you. The flag just tells you run or not run. That's it. And monitors may have more than one more than one test in them, all right? So catalyst efficiency monitor, that only is one test, okay? We just test to see whether or not the cat's any good, and then we move on from there, all right? But evap, like we've talked about before, okay, we have P0440, P0455, P0442, P0446, P1441, P0443, P0449, right? All of those are within that evap monitor. So if that's the case, all of those have to run, and then pass or fail. It doesn't matter if they pass or fail. If it fails, it will set a code. If it passes, it will not set a code. But once it's run all of those, then the emissions flag, the IM status will change to yes. Okay, if that makes any sense. All right, so all that is it says we ran this battery of tests. That's it. We went through the list. The list is complete. That's all a flag means. Okay. So catalyst efficiency monitor, we've talked about this a little bit before. Some of them run it while you're driving, and some of them run it at a stoplight. But you can see here, this is a good pattern, right, for a narrow band. Da-da-da-da, rich lean, rich lean, rich lean. And this right here would be your post cat. That is a good pattern for a post cat. Okay, now I'm going to take a test drive and I'm going to show you that. Now this right here, all right, that's your pre-cat and this is your post-cat. If the car is hot, okay, if the car is hot, and this is page 365, this right here is no damn good, okay? That means that the catalyst isn't doing its job, all right? It's not absorbing and releasing oxygen, it's not converting, okay? If the front follows the rear, or let me restate that, if the rear follows the front, there we go, because the front should be doing high-low, high-low, high-low if it's a narrow band, and it will be doing its job. If the rear follows that, one of two things. Either the catalytic converter is no good, okay, and that's a possibility, or it's not hot enough, okay? So it depends on how hot it is, whether or not it can actually do that test. The other thing, too, is I'm also going to show you on my test drive how the catalytic converter runs that test, okay? And remember we talked about where it'll go cycle, 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 cycle on the front O2, and then when we force it to run that test, it'll go high, and then it'll go low, which drives the rear high and then low, and it waits to see what that time frame is to decide whether or not that cat's any good, okay? And I will show you that because that's important to understand. Okay, so then we're talking about, let's see. Okay, so then it said they have a little blurb here on 366 about efficiency monitor with an air fuel ratio sensor. Basically, the air fuel ratio sensor knows it's a little different pattern because it's not supposed to cycle, but the computer knows where that frequency is supposed to be, high or low, above or below 1 volt, right? So it should know, again, what that time difference is going to be. Let's see, misfire monitors. If a cylinder misfires, and this is important to understand, okay, unburned HC, okay, raw fuel is going to come out of that cylinder, okay, and it's going to enter the converter, and you can flood it, you can ruin it. That's why we go ahead and we turn on the check engine light and make it flash if you have a consistent misfire. What'll happen is you'll overload the damn thing and it will go ahead and melt and it'll just become a blob, all right? And then you'll have exhaust restriction and a bunch of other things. Let's see. Most computers are designed to shut down a misfiring cylinder's fuel injector. Well, yeah, you would hope so. Some of them will, some of them won't. What's interesting is that they'll shut down that cylinder's injector, and then the rest of the cylinders, because the damn thing will still read lean because the valves are still opening and closing and pumping oxygen in there, even if there's no fuel. That's what you have to understand. Anytime anytime a cylinder misfires, you're not only pumping HC in there, which we cannot read, okay? We can't see that. We can only see oxygen because it's the only sensor they give us, okay? So anytime a cylinder misfires and the valve opens, it pumps all of that oxygen right into the exhaust stream. Now, what is the ECM going to see? It's going to see lean, won't it? It's going to see nothing but oxygen. So if it sees nothing but oxygen, what's it going to do? It's going to add fuel because it's going to think it's lean. So even if it shuts down that one injector, those other 3 injectors, it's going to widen the pulse to try to make that sensor swing. It's ridiculous. It doesn't make any sense, but that's what the ECM does as a rule. Let's see. So cylinder misfire monitoring. Well, we've talked about the fact that every time a cylinder fires, the crankshaft speeds up just a little bit. And we watch for that with the crankshaft sensor and the camshaft sensor above, right? And that's how we decide whether or not it's sped up enough, whether it is a misfire or it's not a misfire. Okay. Let's see. So we have type A and type B misfires. Type A could damage the catalyst. That's going to be a consistent misfire. Every time that crank comes around, it doesn't fire. Okay. So that's when it's supposed to shut down the injector. It's supposed to not dump fuel, but usually it does. And hopefully not melt the cat. Type B can cause high emissions over 1.5 times. Okay. Whether it will or not, it's a whole nother story. Whether it will set misfire codes or whether it will set lean codes or rich codes, that's another story. I've had people come in and they're like, "Oh yeah, my car just needs a tune-up." And my immediate question is, why do you say it needs a tune-up? Well, it's running a little rough. Okay, great. 9 times out of 10, that's not a spark plug failure. Okay, not that it can't be, not that it hasn't been, but 9 times out of 10, it's not a spark plug failure. Okay, so then you talk to the customer and you go, "So what's actually going on with the car?" And they said, "Well, it runs rough." And you said, "Okay, well, instead of spending your $180 or whatever on a set of spark plugs just right off the bat, let's go ahead and diagnose that for an hour." That's a much, much better money spent, in my opinion. And so at any rate, they say that with the type A misfire, of course, the SES is going to flash. Type B, it will not. It will just come on and set P0300 or 301 or whatever it is, whatever it's managed to figure out. The thing about it is I've had people come in and go, "Hey, my car's running a little rough. It needs a tune-up." I've talked them out of a tune-up. We've diagnosed it. There are no codes in it, but it does misfire. So you can still get a misfire that doesn't quite meet the 1.5 times emissions that the computer is guessing at. And I say guessing because it's not actually measuring on a 5 gas, is it? It's only measuring oxygen. So that's only an indication of whether or not it's burned. So at that point, maybe it thinks that you're within 1.25 times the output of normal, but it's not enough to set a misfire code, or it doesn't misfire enough times in a row to meet a type B misfire DTC, and it won't set P0300. It misfires, it runs like crap, but you can't get it to set light. So that's not unusual at all. Well, they say it's going to be detected by the misfire monitor. Maybe it will, maybe it won't. I've showed you guys where to find misfires, or we've talked about it in the scan tool, right? And you go to the misfire data list, and it will give you current and history. And we always talk about trying to attack the one that has the most counts, right? That's usually the one that's your issue, right? Okay. If you really want to read all about that, that's page 367. My thought is, if you can feel a misfire, you need to chase it and figure it out. That's my thought. And there are all kinds of misfires. I've had misfires that only misfire on D-cell, and they quit by the time you come to a stop. Those misfires I found have been caused by valves sticking open. But there's no way to duplicate that because it will only do it on decel when it has a vacuum behind that valve, and it will hold it open. So there are lots of things that you're going to have to figure out there as far as misfires. That's one of those feel things, and there's not a whole lot of stuff I can do to describe it. Hi, puppy dog. You're a good girl. Why don't you lay down? Daddy's busy. Okay. Thanks. Okay, so fuel system monitoring. We watched long-term, short-term fuel trim based on percentages, and then we set a code. That's all it is. Okay, heated oxygen sensor monitor. We watch lean to rich, rich to lean, and we watch how much time that takes, right? So if it's a long curve and it doesn't like that long curve, right, because maybe that's 3 seconds, then maybe it will set a code for heaters, right? And remember on the Camaro that I showed you guys, the heaters in the front don't work as well. I'm not as concerned about those because once you run the car, they do cycle, and they cycle in a timely manner, and they don't set any codes. Not that setting the code is my ultimate threshold for whether or not you should replace a part, because there are lots of things that I replace that are marginal. But if it does its job after the car warms up, then you have to decide whether or not it's worth it to you to go ahead and replace it. Let's see. So all the sensors are watched once per drive cycle. So you have to be off for a minimum off time, and most minimum off times are like 8 hours. So the car has to cool down for so long, and then but the computer has a clock in it, so it counts. It knows how long the car's been off, and then it will run those tests once per drive cycle, depending on which ones they are. And some of them are set to run continuously, like misfire. You have to watch misfires constantly, right? There you go. Let's see. They watch it for excessive voltage. They watch it for stuck lean. They do the air-fuel ratio sensors for the same thing. Does it have a short to ground? Does it have a short to power? Is the heater working? Does it do its rich lean swing? Et cetera, et cetera. So, and then they go on to talk about EGR system monitoring. So as we've discussed, and I will show you on the car as well when I go for a test drive a little later, not only do they test for the actual opening on a pintle valve, because they actually have the position sensor for that valve, but they will watch to confirm that even if the valve opens, that we have a change in map, right? That we have high vacuum, then we have lower vacuum when that system is operating. That confirms the fact that that passage is open and clear, which I'm also going to go and check that car again, because I dumped a bunch of GM top engine clean in that passage, and I'm going to see if I can't get it clean for you and dig out some of that crap and show you what it looks like. So at any rate, okay, and then they talk about Ford's DPFE, right? And that works the same. That works the exact same as watching the DPF. They have a sensor before and after the DPF, and they watch for that to change one to the other, and that tells you whether or not that valve is open. Enhanced evap system, like we've talked about. So we test for purge flow, we test for vent flow, we test for the ability to hold vacuum in the system. That's the other thing I want to hope to get to today. If I don't get to it today, I'll post some videos on it tomorrow. R&Ring that pump and replacing that seal. And then what else? We also have the ENOV test, right? Engine off, natural vacuum. So we shut the car off, close the vent valve, close the purge valve, and we watch for that pressure to rise and then fall again in the tank, don't we? Okay, so secondary air injection system monitor. There again, we've talked about that where, and I wish I could get the damn car to run, but I have to replace the distributor if I get to that this week. I will post a video on how to troubleshoot that, and maybe we'll do that as an exercise for next week, for next class for 235. So at any rate, I think that's a good thought. Maybe at any rate, so it's the air monitor wants to know. Air system monitor wants to know: does the pump come on? Does it generate pressure? Does it move air into the exhaust? And can the O2s read it? Okay, so that's how all of that works. That's all on page 371. So at any rate, it watches for the pre-cat O2s to go lean, and if they go lean when the system is on and the valve is commanded open, then guess what? It works and it passes the test. Okay. All right. You know what? That is something that I think we're going to do. We're going to do as an activity this week. We'll diagnose the air system. I'll have to move that SIR file maybe, but there's a SIR file on 134, and I'll move it to 235, and we'll go through that as well, and we'll do our diagnostic that way. But there is an actual sheet for that, and we'll get you guys to watch that SIR file and go from there. I'll do a little video on how to do that. I will give you guys for this coming week my GM password, username and password for those that need it. That way we can all do the activities together. Let's see, thermostat monitor. So they added that in 2002 because they had a lot of cars that weren't making it up to temperature. And that's important, right? We talked about emissions and all of that. So they added that monitor. They have a PCV monitor. I know they'll set codes for it. I haven't really had to mess with it. GM system is 2 tubes, and either it works or it doesn't as a rule. Let's see, comprehensive component monitor. That's any electronic input that can affect emissions. So let's see. So that just watches for values it doesn't like: mass airflow, manual lever position sensor. That's referring to the transmission shifter. Throttle position sensor, accelerator pedal position sensor, engine coolant temp sensor, intake air temp sensor, NOx sensor, system wiring. What that boils down to is it wants to know, are these signals valid? And if they're not valid, then let's set a code for it. So it does a rationality check. That's on page 374. Wants to make sure that everything works. Watches for, let's see. Yeah, so we watch for wide open throttle, AC cutoff. Remember we talked about that. Once we hit 80%, it turns off the compressor. So you get all the power. Shift solenoid 1, 2, TCC. Torque converter clutch will only give you 1 mile per gallon anyway, but they watch it to tell you whether or not it's working. O2 sensor heaters, high fan control, pressure control solenoid, fuel pump control module, throttle actuator control, variable valve timing. All of that good stuff is watched. Okay. It may not have its own specific emissions monitor because it is not emissions equipment, but it all contributes to the overall efficiency of the vehicle. Let's see, and then we talked about readiness mode and the warm-up cycle. Hi, pup. How you doing? And then we talked about the warm-up cycle where we have a certain amount of run time, and then we drive it, right? And then we drive it again. Hi, aren't there any puppy things you should be doing? I think there probably are. Do you need to take a nap? It might be good. All right, so let's see. No, you're going to hang out with Daddy? Okay, you're going to hang out with Daddy. So all of that stuff is going to be on 374 and 375. And some of that is also related to when does a test run, right? When has it met all of its criteria? Hang on just a second. Okay, she wanted to go outside. That's what that was about. Alrighty, let's see. So, yeah, so it'll tell you on 375. They give you sort of a general idea of when all this stuff runs. So, and then if you go to 376, they go through the diagnostics that you have to satisfy to make it run during the drive cycle. More on the DLC, malfunction indicator light operation. I've seen it will set a code, but of course, if there's something wrong with it, it will not turn the light on because the light won't come on. That's about the only function that you get up that's a problem. Have seen things fail for that don't have that work. They go through the different codes again on 378 PBCU, all the different kinds of codes and things and what the numbers mean. Okay, as we talked about before, type A codes run all the time. And they will fail and they will set a light first fail, first trip. Type B DTCs will set a code on the second consecutive fail. That's part of what the keep alive memory is for, that it remembers that it failed that code before and it needs to run it again and then make a decision about whether or not it has to turn on the light or not. So C codes can illuminate a lamp other than the mill on some models, and some models they don't. So if you have a body control code, a lot of the times it will set a service vehicle soon, not a service engine soon. And type D don't ever usually illuminate a lamp, but they will help you diagnose things. P1811 typically falls into that basket. P1811 is a maximum adapt long shift code for the transmission, and typically it won't set a check engine light. I've only seen it do that one time in my 20 years on the line, but it causes havoc when it sets and it defaults to full line pressure and banks to the gears and all that stuff. So at any rate, that's all on 379. Enable criteria, you have to have this, 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 you have to have that. Then the test will run and it does this, 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 and this, and looks for this result. Okay. So let's see. See, mode 1 is the parameter identification mode. So basically that lets you look at the data list. PID, that's it. Okay, mode 2 is freeze frame data access mode, and I'm just looking at page 379 right now. And that lets you look at freeze frame information. Same thing as under DTCs, and that's the thing. When you use a factory scan tool, you don't use any of these modes. You only use what they give you. So that's why I don't mess with it. 9 times out of 10, you guys are not going to use this. You're going to use a scan tool that's better than this, that's programmed to do what the manufacturer intended it to do. So at that point, you're not usually going to need these different modes. That's not something I usually get too excited about. So, and then it goes through all the stuff. Let's see. Reset modes, mode 4, mode 3 permits scan tools to obtain stored DTCs. Mode 5 is the oxygen system monitoring test. This gives the oxygen sensor fault limits and the actual outputs during the test cycle. So that'll help you find a lazy O2. I can usually do that just by watching the data stream. So that's not something I usually get very excited about. Also, GM had an oxygen sensor test when they had the Tech 1. Once the Tech 2 came out, they got away from that. There's not any more a test you can select using the Ch12 that will let you physically test the oxygen sensor. But 9 times out of 10, seasoned technicians can watch how it's moving and they can tell you whether or not it's any good. Also, when we discussed the other day, when I showed you that the O2 sensor would not cycle fully lean, even with the key on and the heaters on, those might be construed as lazy. Just depends. Obviously, I'm going to have to drive that car again before I decide if I'm putting front O2s in it. But right now, the heaters don't really work to spec. So that's one of those things. They don't fail the test, but they technically don't work to spec because the sensors don't fall all the way to lean. Just key on, engine off. Let's see. Mode 6 is the onboard test of non-continuously monitored systems. So that watches all the rest of the stuff. Thermostat, evap, EGR, secondary air, catalyst, oxygen sensor heater, PCV system, heated catalyst. Now, Doc says that he likes this for the simple fact that if you're working an emissions problem and you make a repair, there's just some random number assigned to this. Now, I've never messed with it, quite honestly. I can't tell you what it does, but what it does is it seems to, talking to him, it stacks all of those continuously monitored systems that don't necessarily set a code, and it stacks all those things and does a count, okay? And it assembles the count and it gives you a number, okay? So it like adds them all up, I guess, if you will. What he'll do is he'll make a repair and then go in, let all those monitors run, and then look for that number to be less, because that means a positive change. There's less garbage coming out the tailpipe, according to the computer. Your mileage may vary. I've never used it, and I've fixed, I don't know how many oxygen, or not oxygen, but emissions failures. So at any rate. Let's see. Mode 7 is the monitoring of test results for continuously monitored systems. So 2-trip DTC may be displayed here after the first failure is a pending code, but the information may not be accurate until confirmed by another failure. If the vehicle shows a failure here after one trip, the tech should make sure that the vehicle is okay before returning it to the customer. Basically what that means is it saw it fail once, but it's up to you to make sure that it's fixed before you give it back to the customer. Okay. Let's see, mode 8 is request for control, so that's bidirectional control. That's I'm going to tell the computer to do something. Mode 9, if it's supported, allows the PCM to identify the VIN and the calibration ID and calibration verification. Okay, so we've talked about freeze frame data, and it says it can be used by the technician to see if the latest calibration has been programmed into the PCM. No, not in my experience. Freeze frame data is what happened the first time something failed. Okay, so freeze frame is the set of parameters that we captured when that failure occurred. Remember, failure records will overwrite every time it fails, right? And give you a new set of data. Yeah, so it's on page 381, and they do talk about failure records, which is what we just discussed. Yeah, and then they say, too, a freeze frame should not be confused with a snapshot. Most scan tools are capable of taking a snapshot, which is something that you enable, okay, and then you watch it to try to determine what's going wrong that's wrong, okay. Also, snapshots are great because if you set it to trigger when the DTC triggers, it will set a certain number of frames aside before it triggered and save those, and then it will stop afterwards, and you can watch that snapshot and you can try to determine what went wrong with the car when that happened. Okay. So that's about everything for chapter 12, quite honestly. There's nothing really extraordinarily exciting in there or new. We've talked about most of that. Related systems. So in this case, we're talking about stuff like clutches, drive lines, rear differentials, tires, steering, transaxles, things of that nature. And basically, what it comes down to is the drivability guy has to be the smartest guy in the shop because he has to be able to isolate a failure to or away from the engine. Because we work failures on the engine if we're drivability only, right? Okay, none of us are drivability only anymore. Let's just face that fact. Those days are pretty much gone. But when you get to that point, you have to decide: is the failure the engine shakes? That's your concern. Ooh. Okay, well that was your complaint. So you bring it in, the engine shakes. Well, great. Does it shake when you're on the brakes? Does it shake when you're sitting at idle? Does it shake when you put it in gear? Does it shake when you take it out of gear? Does it shake when you let the clutch out? Does it shake when you put the clutch in? There are so many different variables that you have to be able to basically narrow it down to one section of the car and make it work, right? I had one where the guy was complaining that he had a lack of power. And this is a beautiful problem, right? My car's got a lack of power and it won't accelerate. Okay, so it comes in and the ABS light's on. And my friend Mike was like, "Here, Dave, I don't know what's going on with the ABS. I don't have time to mess with it. Why don't you go ahead and do your lack of power diagnosis and I'll get to it later." Okay, great, Mike. I'll be happy to take it. So I take the car and I take it for a drive and I realize that the car won't accelerate because it's an attraction event. That's why the ABS light's on. And it's setting codes for both rear wheel speed sensors. So I start watching because I'm like, if it's an attraction event, of course it's going to limit power, upshift the transmission, retard timing, pull injection pulse, everything that kills power. So what I did was I watched the ABS because the ABS is what's pissed off. If the ABS is pissed off, it's going to go into a traction event and it's going to limit your power. So I immediately went to watch that, and what I found was the front and rear wheels were off by about 10 miles an hour at 40. And I went, that's not how that's supposed to be. So the only way that that can get off is it's not receiving the correct number of pulses per mile. So I started looking at the tires. Well, this joker had put one size of tire on the front and a smaller size on the back. Ta-da! Great. Good work, you numbnuts. So the sensors didn't agree front to rear, so it went into a traction event because it thought it was sliding. So as a result, that was the entire problem right there. I took care of the ABS line and diagnosed what was going on with the low power issue, all for an hour. And of course, the guy wanted to argue with us. He said, "Well, I'll tell you what. You put 4 tires on it that are the same size, same brand, and come back, and if it's not fixed, then we'll dig into it." And of course, never showed up again. So, ta-da, we fixed it. So at any rate, those kind of things can happen all the time. The other thing that I've seen too on 4-wheel or all-wheel drive is if somebody gets tires that are worn halfway in the rear or halfway in the front because they never rotate them, it goes into a 4-wheel drive event. It locks the front to the rear, and then people have lack of power and what's called crow hop, right? It hops around the corner because it's trying to turn all those wheels at the same speed all the way around the corner, and we know that's impossible, don't we? So at any rate, those kinds of things happen on a regular basis, so just be aware that it's out there. And then transmissions, we get into you're trading speed for torque, right? We've talked about that quite a bit. Torque converters, and we've talked about torque converter clutches as well, and how all that stuff locks together. And then we can get into transmissions and how we multiply torque. Oh, thank you for the snack, honey. I appreciate that. Get to eat apples. So we get into how planetaries work and ring gears work and sun gears work. How all the clutches will give us drive driven and held and give us different gears, right? How valve bodies move a valve inside a spool valve and it changes the flow of the hydraulics to make something happen down in the gear set, right? So at any rate, Chapter 13 has a lot of that. The other thing too, we get a lot of complaints too on 4-wheel and rear-wheel drive vehicles about drive shafts and vibrations. That's page 403. So just be mindful of the fact that if you have a vibration, right, or the customer complains that the car shakes when they drive it or accelerate or whatever, it may not be the engine. It might be in the drive shaft. You might have a bad U-joint. I actually have pictures where the bolts on this Ford Expedition are backed out that far from the actual flange plate. So the flange plate's doing this as they're driving. And naturally, if you don't hold the flange plate steady and let the U-joint do its work, it causes a vibration. So that's always exciting. I'll try to post some of the things that I've seen. It's pretty ridiculous. Also, as you guys learned a little bit in first year, but you'll get into a little more, I think, in second year, is the U-joints have to work at a given angle, right? So this angle has to be the same as this angle. So you have a U-joint here and a U-joint here. And if the working angle is not the same, then you cause a vibration. It has to be within a half a degree. So that's real important. You may need to go pinion up, pinion down, transfer case up, transfer case down to make that right. Heating and air conditioning. This is a good one. Just be mindful too. Chapter 13, I'm not really testing you on. This is stuff that's good for you to know. That's why I cover it. Also, I have a fair amount of experience with this, and I have run into a lot of different issues like this. So heating and air conditioning, that can cause a couple different things, right? My car surges. Me. Okay, so the car comes in, customer complains that it's got a surge. You take it out and drive it, and it's the first week of April, and they've turned the air conditioning on, okay? Well, guess what? It's low from last year, so the clutch is going on, off, on, off, on, off, on, off. So the car's going on, off, on, off, on, off, on, off. So there's your surge. Presto. Fixed. Figured out, right? Another one that we see more often on the North Star engines. I'm not sure why it's the North Star engines, but it seems to be pretty prevalent for those. So that'll be Cadillacs and the occasional Oldsmobile Aurora. The compressor clutch likes to get fried, and sometimes it sticks on. And when it sticks on, the engine is trying to turn that compressor, and sometimes that compressor locks up. So you're trying to drive it, and they're like, "My car's got a lack of power." Well, yeah, and the belt's burning up, and it smells awesome under here. So there's that. The other thing I've seen too is it won't start. It won't crank fast enough to start, and the compressor actually is locked up to a point that it won't allow the engine to turn. So never write off the fact that if you get a no start, I've had a couple of them now, cranks no starts, right? So that's drivability, isn't it? So it'll come in and you'll check fuel pressure, injection pulse, spark, blah, 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 blah. And all of that's fine, right? And you can't get it to spin fast enough to check compression or anything else, but you can usually hear that, right? We remember that from the ASE 130, right? When we pulled all the plugs and we cranked it and went wee, right? Okay, so you can hear that it's got compression. It's trying. It just can't make it happen. Take off the accessory drive belt. I had one. It took me an hour to figure it out because I was retarded and not thinking very well. And it was about 105 degrees. But I finally went, I've been through everything. It almost has to be something mechanical, so let's pop the belt off. So I popped the belt off, bang, and it fired. AC clutch was stuck on, and the compressor was trashed, and it wouldn't let that North Star start. So at any rate, so there you go. That's for air conditioning. Let's see, cruise control. They go through that a bit. Obviously, the older systems either have an electric motor that pulls on the cable. That's the better system. The even older ones than that have a vacuum system that pulls on the cable. That's great until you get a leak in the vacuum system somewhere, and then it doesn't work very well. And then you turn it on, and it's just like the air conditioning, you know, blows on your face, and you start going uphill, and we talked about it, and it drops to the floor. Same thing. The cruise control drops off, and the car slows down because it doesn't have enough vacuum to run it. They go through the brake system. So here's one for you. So the people complained, it's got this shake when I drive it. Okay. Take it out and drive it. Guess what? It shakes on D-cell. Brakes are warped. Okay. There's one. Another interesting one too that is along the lines of that, but different. We had one this way, and the lube kids that never really wanted to diagnose anything but would cut rotors and do brakes all day long, diagnosed it themselves, and they cut the rotors three times, and it still shook on braking. And we brought it in, and Mikey and I checked it out. Tire rod ends were loose. That's why it was doing it. So they checked the brakes, but they didn't check the suspension. So at any rate, that's something to keep in mind. Everything has to be held still when you're braking. Otherwise, any movement transfers itself as a vibration to the car. Also, most brake boosters are vacuum boosters. And you can hear if they have a leak, you step on it, it goes whoosh inside the cabin. Some of them will just flat out leak, and they will sometimes set idle codes, or the customer will complain that the car idles high. And you come in and you find a vacuum leak from that booster, and you have to change the booster. Steering suspension we talked about a little bit. Make sure the stabilizers are good, ball joints are tight, tire rod ends are tight, all that kind of good stuff, right? One of the other interesting things I've seen, if you have Hydro Boost, where it runs from the power steering pump to the booster, down to the steering gear and back to the pump, what can happen if you have a bad rebuild? You just asked me how I know. Anyway, I didn't rebuild it, but I did replace it. You step on the brakes and the wheel turns. That's always exciting. So then you have to put a new Hydro Boost in it. They also bring up steering suspension and alignment, because if the tires are not square to the road, right, like that, then you're going to put in a lot more effort to make that car go down the street, and you're going to wear tires and throw money in the trash can, things like that. And talk about wheels and tires. It doesn't happen too much anymore. Usually everything is a radial tire. Almost nothing is a bias ply anymore, except for the biggest trucks, like big over the road trucks. Even our 1 tons and 1.5 tons and stuff still use radial tires. Tire and wheel balance. That's an interesting one. Yeah, I've had an interesting one. They said it came in with a vibration, and I checked it out and drove it and all that, and I'm like, God, this feels like prop shaft. It was that bad. It was awful, terrible. So I measured it. Run out was out of spec, so I put a prop shaft in it. It was better, but it still wasn't fixed. So I wound up putting the EVA on it. No, I was going to put the EVA on it, but the Pico had just come out, and I had just been trained on that. And so I went ahead and I put the Pico on it, and it wound up being tire balance. Amazingly enough, I have no idea how the tires produced that weird frequency, but they did. But the Pico found it, which was good. So at any rate, so I rebalanced all the tires, and they were off by between 2 to 4 ounces. That's how terrible it was. Right out of the factory. Truck had like 1,500 miles on it. It was pathetic. No, that's good, honey. I'm pretty much done now anyway. So that's chapter 13. If you guys have any questions on any of that, let me know. Okay, let me know. I'm gonna go make a variety of small videos in the car. I've got quite a list at this point of stuff that I want to do, and I'll start posting that too. But I'm gonna go ahead and get this up now, and then you guys will be able to access this and move on with your lives. Also, as a request from Micah, because he has more time today than tomorrow, I'm going to go ahead and open the final early, and you'll be able to go ahead and access that and knock that out today if you want to do that. So have a great day, guys. Great talking to you. Love you all.